Okay, I'm back to finalize with the ordinal utility approach. Yeah, I said in this approach the assumption that utility is measurable using cardinal units is dropped. Instead, a consumer is faced with a bundle of commodities from which he has to make a choice. You're presented with a bundle of commodities and you make a choice from those bundles. Yeah, I gave an example that one bundle could be a cup of coffee with 2 pieces of bread, and the other bundle is 2 cups of coffee and then 1 piece of bread, and you have to make a choice. Yeah, based on what you prefer. Do you prefer to have more tea or you prefer to have more bread? All together. So those are the bundles you're presented with and you make a choice. That's the approach. But let's understand more the ordinal approach, and we can get a clear understanding of it by looking at its various assumptions. The first one was the consumer is assumed to be rational. This applies with the earlier approach. In this, the consumer aims at maximizing satisfaction given the income they have on the market price. The treat as ordinal. Yeah, the consumer can rank its preference. Yeah, and then we talk about diminishing rate of substitution, and this comes from the indifference curve, meaning we will understand it more when we get to the indifference curves. The other assumptions are that the utility of the consumer depends on the quantities of the commodities consumed. The total utility will consume the quantities consumed. And then there is an element of the uncertainty, greed. Yeah, so here we assume the consumer is never satisfied. You either want more of X or Y or both, meaning you choose, or the consumer will always choose a bundle that contains more of X or Y. Recall, so in this case my bundles are, or my bundle is made up of, let's say X is tea and then Y, or a cup of tea and then Y is bread. Yeah, so if you're presented with bundles, you always wish to choose the one which contains more of X or of Y, because that's our nature. Yeah, consumers are naturally greedy. Alright, and then there is that element of consistency and transitivity. Okay, here we assume that the consumer is consistent in his choice. That is, if at one time you prefer combination A to combination B, yeah, you will not prefer combination B to combination A in another period when both bundles are available to you. Okay, yeah, so consistency. Now, if I preferred combination A to B, I have to be consistent in that I should always prefer A to B, provided they are both available. Not to change. Today I'm preferring combination A to combination B, and then tomorrow I'm preferring A to B. No. Here we assume you have to be consistent in your choice. Okay? Yeah. And then the element of transitivity. Yeah, if combination A is preferred to B and B is preferred to C, then automatically A must be preferred to C. That's transitivity. If I'm preferring A to B, but I prefer B to C, then automatically I prefer A to C. All together. So you're preferring combination A to B, meaning A is greater than B to you, but B is greater than C. Then automatically A, the first one you first preferred, has to be preferred what you preferred last. Yeah, that's the element of transitivity. You shouldn't confuse us. You're preferring A to B, but you prefer B to C, and then you tell us I prefer C to A. Yeah, then you'll be confusing us. There is no way you prefer C to A when you're preferring B to C, for which you prefer A to B. Altogether, that's the element of transitivity. Okay, in simple terms, to explain it, moving away from the bundles, the element of transitivity, you say I prefer Coke to Pepsi, but I prefer Pepsi to Fanta. Then automatically prefer Coke to Fanta. Yeah, it won't be too wise if you tell us I prefer Coke to Pepsi, and then Pepsi to Fanta, but I prefer Fanta to Coke. You'll be like, well, you know, yeah. So the method positivity brings out that. Okay, and then let's talk about a difference curve. Yeah, this approach at times is called a difference curve approach. So we may need to get a clear understanding of the indifference curve. What is an indifference curve? Okay, the indifference curve is a locus of point showing two commodity combinations that yield the same level of satisfaction to the consumer. Yeah, it's that curve which will show us two commodity combinations that yield the same level of satisfaction to the consumer. Yeah, it's negatively sloped. Yeah, this is the indifference curve. All together. So in this curve, we are having good x and y. We are having good x and y, and we are saying that on that curve, each of those letters stands for a combination of x and y. Yeah, and each letter or each point of satisfaction or combination on that curve will yield the same level of satisfaction, meaning A gives the same level of satisfaction as B, as C, and as D. But what difference is at A, there's difference in the amount of x and y altogether. At point A, we have more y and less x altogether. At point B, we have still more y and less x. Of course, there's difference in the amount, right? And then at point D, we have more x and less y altogether. So as a consumer, you may choose to select any point altogether. You may choose A if you want to have more y than x, or you may choose D if you want to have more x than y. But the issue is each of those points will give you the same level of satisfaction, but the difference is the amount of x and y you're having in that combination. But each of those combinations will give you the same level of satisfaction. We are calling them combination because at point A we are having some elements of y and then some elements of x. So it's a combination of x and y units. Okay, that's the indifference curve. Yeah, that's the indifference curve. Let me try to illustrate more this curve. Let's get back and then we'll try to illustrate more of that indifference curve. Let's draw it. Yeah, let's draw this curve again and then we illustrate it. Let's draw it. Let me have this. I'm having this here. Alright, then I'm having this here. So assuming here I'm having, let me put on this axis we are having let me say Coke. We're having Coke. Yeah, we're having Coke. And this side we are having, and this side we are having, let me say Godsmith. Okay, cakes. Let me say cakes. Let me not use Godsmith, cakes. And then we are having our difference curve. Let me see if this curve will come out. Trouble. So on that line curve, okay. Oh good, make this curve shoop, pause a bit and then shift. Trouble. Yeah, let me try to draw this curve. Pause a bit. Yes. Okay. Alright, so this is my curve. All right, so we are going to try to put different points on this curve. Yeah, it may not be that perfect, but you know. All right, we are having Coke and cakes right together. Yeah, so you're going to see how we create bundles, so how bundles come about. Yeah, and what makes up a bundle? Yeah, a bundle is made up of two combinations of two commodities, right together, the cakes and cokes and Coke. So when you put all those combinations on that curve, then that curve gives us or becomes the indifference curve. Let me assume, I'm going to assume numbers. Yeah, Coke in terms of bottles. Yeah, so we're having that point, and we assume that at this point we have 4. We are having 4. Okay, at this point we are having 4. Let me move this. We are having 4 cokes or 4 bottles of Coke. Okay, 4 bottles of Coke. All right, 4 bottles of Coke, and then we are having 2 cakes, and we are having two cakes. 2 cakes at that point, all together. So this combination is made up of. So this combination is made up of 2 cakes. 2 cakes. Okay, let me write it. 2 cakes, and then 4 Coke. Yeah, I wouldn't say 4 cokes. So that's a combination. Let's call this combination A. That's combination A. That combination is made up of 2 cakes and 4 Coke, or 4 bottles of Coke. Let me try to make this a bit more visible. Alright, so that's a point on our indifference curve. That's a point on our indifference curve. But there could be another point. Let's say there could be another point. There could be another point. A point here. Let me say at this point there are 3. There are 3 cokes, and then let's move it. This maybe it connects to that point. Yeah, and at this point we have let me say and at this point we have, let me say 1 2 3, we are having 4.5 cakes. So the combination at this point would be, let me say this is point B, this is point B. Yeah, at point B we have 4.5 cakes, and then 3, and then 3 cokes, and then 3 cokes. I'm just assuming this, I didn't measure the axis and everything. Okay, yeah, so you're having point A and point B. So we are saying under the indifference curve that each of these points offers the same level of satisfaction. Together, this bundle A and bundle B will offer a consumer the same level of satisfaction. However, if you look at them clearly, you'll find that one has more cakes. Altogether, one has more cakes, and the other one, okay, this one has more cakes, and then the other one has more Coke, almost sodas. Altogether, let me call this 4. Let's make this to be 4. Yeah. Altogether, one is having more cakes, and then the other one is having more Coke. Altogether, so as a consumer, you can now look at these bundles. Recall they both give you the same level of satisfaction, but you can look at them and you're like, me, I prefer cakes, or I prefer having more cakes. Together. Since I prefer having more cakes, let me go with option B. For option B has more cakes and few sodas. Yeah, but someone may say, no, I prefer taking more sodas, so I'll take option A, which has more sodas and few cakes. So this is how this approach works. You're just going to rank those bundles and you choose the best, the one which you prefer. Together. But recall, each of those bundles will offer or give you the same level of satisfaction. The other thing you can see here, or the other thing you need to know, we're talking about the indifference curve being negatively sloped. Yeah, being negatively sloped. Like you're saying, yeah, when cakes increase, cokes reduce. You could see it. Yeah, when the number of cakes increased, the number of cokes reduced from 4 to 3 altogether. That's the negative slope we're talking about. Yeah, or the marginal rate of substitution. Meaning you have to give up some units of one commodity to have more of the other commodity. You have to give up a soda to have 2 extra cakes altogether. Yeah, so that's the negative slope of the indifference curve. Yeah, it's negatively sloped. We may need to revisit this curve again when you're looking at the properties of the indifference curve. We may need to revisit it. Alright, let's continue. Okay, yeah, alright, so this brings us or shows us how we calculate what you give up. It's changing y over changing x. To know how many units of y you have to give up to get an extra unit of x. Yeah, we do that based on change or using that formula, changing y over change in x, but this was referring to the area example. Changing y over changing x to know how many units of how many units of y you have to forego to have an extra unit of x. How many units of how many cokes or how many sodas you have to forego to have an extra cake. We do it. We just calculate that. We don't assume. You just get the change in y over the change in x. And how do you get change? New minus old. Okay, so the magnitude of substitution, I talked about this, but just here we are revisiting it. Negative slope of an indifference curve. It shows the amount of units of y that must be given up to exchange for an extra unit of x. If we go back to our example, it will be the amount of units of coke you have to forego to have an extra unit of cake. And to get it, you have change in y over change in x. In this case, it would be change in y. Yeah, in this case it would be our change in y. Okay, let's calculate this. Yeah, we are calculating the magnitude rate of substitution here. We are saying it's change in y, change in y, change in y over change in x. In this example, it would be our original y was 4 and our new y is 3, so it would be 3 minus 4. 3 is our new y. Recall we moved from 4 to 3, so 3 is our new y and 4 is our original y, divided by the new x, which is 4, minus the old x, which was 2. So in this case, right, sorry about that. Alright, yeah, so this would be minus 4 minus 2, 4 minus 2, 4 minus 2, and I was saying 4 is our new x or our new x, minus our old x or our old x, which was 2. Alright, so this would give us 1 divided by 2, which is the same as it's negative 1, which is the same as negative 1, and negative 1 divided by 2, and this gives us negative 0.5. So this would be Yeah, so it means if you're to get an extra cake, you have to forego 0.5 units of coke, or you have to forego half a coke, have an extra cake. Yeah, you have to forego half a coke or half a soda to have an extra cake. Meaning, if you need to have 2 extra cakes, you have to forego 1 full soda. Yeah, that's the imaginary rate of substitution. Yeah, and that's how we calculate it. Okay. Alright. Difference map. Difference map. Yeah, an indifference map is a collection of several indifference curves, where a high indifference curve shows a higher level of satisfaction. We talked about an indifference curve, but there are several indifference curves indicated. Yeah, remember on those indifference curves you have a combination of 2 commodities which gives a same level of satisfaction. Those combinations could be several, though at times we just highlight a few. That's why we think of an indifference curve, a collection of several indifference. An indifference map, which is a collection of the several indifference curves. Then the properties of the indifference curve. The properties of the indifference curve. There are several properties which makes us understand more the indifference curves. Yeah, and then the first property is an indifference curve which lies above and to the right of another shows a higher level of satisfaction. Yeah, so a higher indifference curve shows or will give the consumer more satisfaction. Let me go back to our indifference curve and you see, okay, let me use this one. Yeah, indifference curve 2 is higher than indifference curve 1, meaning indifference curve 2 offers more satisfaction than indifference curve 1. And so does indifference curve 3. It gives more satisfaction than these two, indifference curve 2 and indifference curve 1. Why? It's because on a high indifference curve, a consumer will consume more of y and x. Yeah, the amount of x and y on indifference curve 3 will be higher than those of indifference curve 2. And recall we said as consumers we want more. That's why we are saying indifference curves which is above and on the right will offer more satisfaction, and that would be preferred. Alright, let's look at the other properties. Yeah, the slope of an indifference curve is negative. This is because for a consumer to increase the quantity of commodity X and remain at the same level of satisfaction, it must reduce on Y. I was talking about this. I talked about that. If we were to increase on X, we have to forego some units on Y, and that explains the negative slope of the indifference curve. And then an indifference curve is convex to the origin, which implies that the slope of an indifference curve diminishes downwards. Meaning, as we'll be calculating, or if you calculate as you go down, okay, you'll be foregoing few units. You'll be foregoing few units of y to have an extra unit of x. Yeah, because you have to consume, or you wish to consume some units of y too. So as you go down the slope, you'll be willing to forego few units of y to have an extra unit of x. Indifference curves don't intersect. Otherwise, the point of interaction would imply two different levels. I'm talking about that. Between two indifference curves, there are many other indifference curves. Between two indifference curves, there are several. You're seeing here we're having, I say, indifference curve 1 and indifference curve 2. Actually, in between indifference curve and 1 and indifference curve 2, there are several other indifference curves probably we've not put. Yeah, even in between indifference curve 2 and indifference curve 3, there are several other indifference curves we may not have talked about. So in between two indifference curves, there are several other indifference curves. Actually, meaning there could be satisfaction, or there could be combinations in between those. In between that. Alright, so read about price consumption curve, income consumption curve, and living a demand curve. Yeah, but I'm going to talk about before we go, I'm going to talk about the element of indifference curves not intersecting, where we're saying that indifference curves should not intersect. I'm going to talk more about it. I'm going to illustrate that. What happens if they intersect? Why are we saying they shouldn't intersect? Let me use this one. Let me just copy it. I put it here. Let's have our new slide here, and then let's paste our old slide there. then I delete that. Indifference curves don't intersect. Indifference curves should not intersect. Hope it's the right SP. I will rectify that. They shouldn't intersect. They shouldn't intersect. Intersect. It has to be intersect. Intersect. Yes. Yeah, that one. Let me first remove this. Let me first remove this. Let me remove this. Let me remove that. Let me remove that. Let me remove that. I should also remove this. Yeah, we are going to explain why indifference curve shouldn't intersect. I'm also removing this. Yeah, I want us to talk, alright, about indifference curves not intersecting. What happens if they intersect? Well, he's saying they shouldn't intersect. Alright. Yeah, could that be a problem if they intersect? Copy. Post. Alright, thank you. It has come properly. So I'm having two indifference curves. Yeah. This one, let me call it indifference curve 1. Okay, indifference curve 1. Let me put it in yellow. Then here, okay. Indifference curve 2. Let me put this in a knob. Indifference curve 2, knob, indifference curve 1. Okay. So you're saying this should intersect. I want to see why. Let me call this point A. Point A, where these two are intersecting. Alright, so you're saying this curve shouldn't intersect. This shouldn't happen. That point A. Why? For them give us different levels of satisfaction. They'll confuse us as to which curve gives us more satisfaction than the other. So if I may ask you now to tell me which of those curves gives you more satisfaction. Recall I just talked about a higher indifference curve giving more satisfaction than a lower indifference curve. Altogether. With that in mind, it would mean that indifference curve 2 is more satisfying than indifference curve 1. Yeah, than indifference curve 1. Based on that. Yeah, based on the fact that an indifference curve which is on top and on the right gives more satisfaction than the one which is down. It should mean that indifference curve 2 gives more satisfaction than indifference curve 1. But this point A can make us change our mind altogether. Recall we said when we're talking about consistency, when we're talking about transitivity, yeah, those elements, yeah, like actually even before that, when we're talking about the points on the same indifference curve giving the same level of satisfaction, all that can explain this point altogether. If you look at this point A, it's a point on both curves altogether. Yeah, it's a point on both curves, and given that it's on both curves, it would make us think that curve 1 and curve 2 offer or give the same level of satisfaction altogether. By having that point A, it would mean that indifference curve 1 and indifference curve 2 offer the same level of satisfaction because that point lies on both the curves altogether. But we are seeing that one indifference curve seems to be on top or higher than the other indifference curve, which would make it be more satisfying. Yeah, but besides that, they have a point in common, which means that point A lies on indifference curve 1 and indifference curve 2, which would mean having the same level of satisfaction. That's why we say indifference curves shouldn't intersect. For they will confuse us, they will give us several or make us think about different levels of satisfaction altogether. Like here we are thinking that indifference curve 2 offers more satisfaction than 1, but now we are thinking they both offer the same level of satisfaction. So to avoid that, the indifference curves should never intersect. Shouldn't intersect. Thank you very much. I repeat, please go through these statistics. Yeah, read about the price consumption curve, the income consumption curve, and how we can derive the demand curve using the indifference curve approach. Thank you very much.